Abstraction and Inheritance. In this video, we will discuss how classes can relate to each other through hierarchies. Abstraction. Scenario 1. Suppose I need you to run an errand for me. Suppose I need you to go to the Apple store and buy an item for me. Then you ask, what do you want me to buy? And I simply respond, a smartphone. Obviously, this wouldn't be specific enough information because there is no item simply known as a smartphone. The word smartphone is an abstract concept, a general term used to describe any phone device that can also act as a computer. Scenario 2. Now suppose the next day you notice a friend and I are returning from the zoo. You then ask, what animals did you see? And I respond, we saw mammals. Once again, non-specific information is given because there is no such thing as a mammal. The word mammal is an abstract concept, a general term for any species that is warm-blooded, has hair or fur, mammary glands, and several other characteristics. Scenario 3. Suppose I'm in need of a workout partner, so I invite you to attend the gym with me. You respond, sure, but then ask, what will we be working out today? And I simply respond, a muscle. Once again, non-specific information is given. There is no body part that is simply known as muscle. The word muscle is an abstract concept, a general term for any body part that contracts to produce movement. In summary, an abstract concept is anything that exists in thought or as an idea, but has no actual concrete existence. This does not mean, however, that abstract concepts are not useful in programming. They are very useful in programming because they allow us to group entities that share common traits. This ability, as you will soon see, will allow us to reduce complexity in our programs. Up until now, we've only discussed classes as separate entities. We've never discussed how classes can relate to one another. That discussion begins now. Class hierarchies. As mentioned earlier, a muscle is an example of an abstract concept or abstract entity. From this entity, we can derive more specific entities such as lower body muscle, upper body muscle, core muscle. And then from these entities, we can derive more specific entities such as quadricep and hamstring for the lower body muscle, bicep and tricep for the upper body muscle, abdominal and oblique for the core muscle. Smartphone was another abstract concept we mentioned. From smartphone, we can derive iPhone, Android, Motorola. From iPhone, we can derive the iPhone 14 or iPhone 15. From Android, we can derive Galaxy S24 or Google Pixel. And from Motorola, we can derive the Edge Plus or the G Stylus. And the last abstract concept we discussed was mammal. Obviously, from mammal, we can derive even more specific concepts such as cat, dog, primate. And from cat, we can derive lion and tiger. From dog, we can derive wolf, fox. From primate, we can derive ape and monkey, so on and so forth. These are all examples of class hierarchies. Now, how do we code a class hierarchy? We start by writing out the class for the abstract concept. In this example, the smartphone class. Then inside that class, we're going to declare all the information that'll be common to all of the classes inside this hierarchy. All smartphones have a brand. All smartphones have a name. All smartphones have a year. All smartphones are going to need a constructor to initialize that information. And all smartphones are going to need setter and getter methods for each of those variables. Hence why we're declaring all of that inside the smartphone class. Once the abstract class is complete, we can then start adding classes to the hierarchy. For example, iPhone. We can declare public class iPhone extends smartphone and leave it empty for now. We can then declare public class Android extends smartphone and leave that empty. And thirdly, we can declare a public class Motorola extends smartphone and leave that empty for now. Now you might be wondering, what do I mean by extends? When class B extends class A, class B inherits all of the variables and methods defined inside class A. What this means is that although the iPhone, Android, and Motorola classes all appeared to be empty, they technically are not because they contain everything that was declared by the smartphone class due to inheritance. To understand why this is useful, imagine for a moment that the extends feature did not exist. If that were the case, then all of the variables and methods that were declared inside the smartphone class would have to be rewritten inside iPhone, Android, Motorola, and any other class that's part of the smartphone hierarchy. By taking advantage of the extends feature, however, variables and methods that are shared by all classes in that smartphone hierarchy will only have to be written once in the smartphone class. Thus, the iPhone, Android, and Motorola classes will only have to contain features that are specific to them individually. The is_a property. Just as there is a correct way to use the extends keyword, there's also an incorrect way of using the extends keyword. Whenever we assert that class B extends class A, we are implying that B is an A. For example, an iPhone is a smartphone. A quadricep is a leg muscle. A monkey is a primate. A tiger is a cat. A Lamborghini is not a shoe. If Class B and Class A do not have an is_a relationship, then it is not appropriate to use the extends keyword to relate them. For example, it would not be appropriate to declare a Lamborghini class that extends the shoe class. The Java compiler will allow it either way, but this is another example of a situation where you will have to think like a human and not a computer. Computers don't know what mammals are. Computers don't know what smartphones or muscles are, but we as humans do. Thus, it's our responsibility to make sure that the extends keyword only gets used appropriately.